we worked number 1 in class and then ran out of time. So working through the rest of these linear inequalities, like I mentioned in class, it's going to work a lot like just solving the equations. There is one extra little rule, and I think we're gonna find it here on this problem. But for the most part, let's work it like we do equations. Let's start with the 3, right? We are going to have to get rid of the 3 and the negative 2, but let's do the 3 first since it's addition and subtraction. Now it is a positive 3. That negative goes with the 2. So let's try how to get to the next slide here. The positive 3 needs to be subtracted to the other side. And then we are left with a negative 2x less than or equal to 8. Now with these videos, you can pause me. I'm going to run through them kind of quickly here, but you can absolutely pause, write down, rewind, fast forward, whatever you need to do. Okay, so negative 2x is less than or equal to 8. Now, at this point, we do need to get rid of the negative 2 attached by multiplication. So we're going to divide by negative 2. But this is where that extra rule comes in. We have to flip this inequality only if you are multiplying or dividing by a negative number. So write this rule down. If you are multiplying or dividing by a negative number, you have to flip your inequality. We didn't run into that on number 1 because we were dividing by, hang on, I went back too far. Number 1, we wound up dividing by a positive 0.20. So we didn't have to worry about it there. If your bottom number is positive, it's no concern. But if you wind up dividing by a negative, you do have to flip that inequality. So that less than or equal to is going to flip to a greater than or equal to. Okay, so the negative 2's cancel. We get x is greater than or equal to a negative 4. Okay, so anytime that bottom number is negative, you are going to have to flip that inequality. So we have solved it. Now it wants us to write our answer in interval notation and graph. So interval notation is that one with the starting point, comma, stopping point, and it's got the parentheses and brackets. I actually prefer to do a graph first, just because I'm a visual learner. So I would probably just grab some scrap paper and draw that inequality out on my number line. But I'll pop them both up here so we can see them. So I would do greater than or equal to the negative 4. So I know I'm going to have to shade everything to the right of negative 4. I'm going to put a bracket on the negative 4 because of the or equal to symbol. And then from there, I would be able to go to my interval notation. But my math lab is going to prefer that you do interval notation first. It's going to ask you that question first. And then it will give you multiple choice which one's the correct graph. Okay, so like I said, if it was me working it, I would have to write it down on some scrap paper and see that graph before I could actually do interval notation. Okay, number 3. Same idea. Solve, write your answer in interval notation, and graph. So on this one, we've got x's on both sides of the inequality, and our first step is going to be getting to the same side. If it were an equation, we wouldn't necessarily care which side of the equation you move those x's to. But with the inequalities, it is going to be drastically easier on you if you will go ahead and move them to the left side. Okay, so let's take that positive x and we're going to subtract it to the other side. Now that does put us working with negative x's, but that's okay. Believe me, it's easier than the other option. All right, and then we can take our minus 4, add it to the other side. So we're left with a negative 3x greater than 9. We are going to have to divide by the negative 3. Anytime you multiply or divide by the negative, you have to flip your inequality. And I'd write that in there in your notes just so you remember that it did actually change. It wasn't just a fluke, that symbol changed directions. That is a must. So we get x is less than negative 3. Okay. So interval notation and graph should look something like this. We're going to shade everything smaller than the negative 3, but we do put a parenthesis on the negative 3. It's not actually part of our answer. And our interval notation is going to start with our lowest number. Remember, it's always important to start with the lowest, negative infinity. And we're going to stop it at negative 3. Everything gets a parenthesis. Okay, I did want to show you what would happen if, you remember at the very beginning I said we want x to be on the left-hand side. If it didn't happen that way, I wanted to show you, and I clipped it from the book, so it's a different setup than the way I saw them. But if you've got that negative 2x, let's think about adding it to the other side. And let's put if we wanted to keep x positive, let's think about it that way. The 3x plus 5, we would then subtract a 5 from it. So we wind up with negative 9 is greater than 3x. We do need to divide by 3. Now we are not going to flip our inequality here because we're dividing by a positive number. Okay, so we wind up getting negative 3 is greater than x. Now that is so backwards for me thinking about trying to put that on a number line, that negative 3 is going to be greater than x. It's just hard to read because we're used to seeing x first, inequality symbol, and then your number. Okay, so if you find yourself in this position by some mistake, if you do find yourself in this position, just know that you can flip-flop the x and negative 3. It's running it off here. If you do flip-flop that x and negative 3, you do have to change that inequality symbol as well. Okay, so our greater than or equal greater than becomes a less than. And that is exactly what we had over here. X is less than negative 3. But like I said, it's just awkward to think about that x last. If it was an equal sign, we wouldn't worry about it. But with these inequalities, it's just weird. So flip it back, but remember to flip that inequality too. Okay. Now, if you don't like this, don't use it. Okay, insist that you always bring x to the left-hand side, and you won't have to worry about that. Okay, number 4. We're just getting into some bigger, meaner-looking inequalities. We've got some parentheses now. So that's going to be where we start. We're going to distribute the 3. We're going to distribute the 4. Okay, so we get a 3x plus 9 greater than or equal to 4x minus 8. Now the 3 doesn't get multiplied by the 4 because it's not in the parentheses, right? So we're left with that. There's no more parentheses, but we could combine like terms. See this minus 8 and a plus 3. We can go ahead and combine that and get a minus 5. And then we need to get our x's on the left-hand side, right? We always want to put x's on the left-hand side. Even though it's going to make it a negative, we still want to do that. Okay, so we have a negative 1x plus 9 greater than or equal to negative 5. And we can subtract the 9. So we have negative x greater than or equal to negative 14. Now, we do have to get rid of the negative with that x. Technically, it's a negative 1. It's being multiplied by the x. So let's divide by negative 1. Now, dividing by a negative, you do have to flip that inequality. So now we're looking at, man, it's too low. Why is this too low? We are looking at a x is less than or equal to 14. X is less than or equal to 14. So, graphing, interval notation, we've got to shade everything less than or equal to 14. So we're going to put a bracket on the 14 and shade everything to the left. We have flipped that inequality, right? It was a greater than or equal to, it's now a less than or equal to because we divided by the negative 1. And our interval notation, we said we start at negative infinity. We always do a parenthesis there because you can't include it. And then we will stop it at 14. And we did a bracket on the 14 because of the or equal to. All right. Oh, okay. I didn't put a number on this one because this one works out kind of weird. If you ever wind up in a reason where whenever you're moving that to the left-hand side, that 9x, if it's going to cancel on the right-hand side, but if it also cancels on the left-hand side and your x's disappear, if you ever find yourself in the scenario where the x's have disappeared, you're not going to have a normal answer. Okay, this is going to be one of the weird ones. So it really depends a lot on what's left. Is that a true statement? Is that a false statement? That determines what your actual answer is going to be. So ours is a false statement, right? 7 is not actually greater than or equal to 54. So because it is a false statement, that means we're going to have a no solution. There is no x value. You can plug in up there and left-hand side be greater than or equal to the right-hand side. There's nothing. It doesn't exist. No solution. Now, my math lab, your book, prefers to use this 0 with a line through it. Okay, it's called the null set. It's just no solution. Graphically, it's an empty number line, right? You can't put any dot there because that would mean it's an answer. So no solution is going to be an empty number line. Now, if it were a true statement, which again, ours is not, but if it were a true statement, your answer would be everything from negative infinity to positive infinity. Every single thing would get to count as an answer. Okay. Graphically, that would mean that you are going to shade everywhere. Everything's an answer. There is no parenthesis bracket stuff going on. It's just everything on the number line gets to count as an answer. Okay, so if your x's drop out, you are going to find yourself in either a false statement, meaning no solution, empty graph, or if it were a true statement, then everything gets to count. Everything is an answer. Okay, so know that stuff. Compound inequalities. Yeah, let's go ahead and talk about this one. I get 15-minute videos, so I'm trying to make sure that I'm not going to make this be too long here. Okay, a compound inequality is one where you have x sandwiched between numbers. Okay, and we said typically they're always going to be less than symbols. Okay, because -3 is in fact less than +3. So solving these, I want you to think about it as 3 sides. You know, we're used to adding 7 to both sides of the equation. It's always both sides of the equation. But now you've got 3 sides of this equation. Okay, so you've got the left side, you've got the middle side, and you've got the right side. Now, we are going to solve for x, which means we're going to have to get rid of the 2, we're going to have to get rid of the 1. But do the 1 first. It's a +1, so let's subtract 1 from all 3 sides. So we're getting a -4 less than 2x is less than or equal to 2. And now you can divide by 2 to all 3 sides. So you get -2 is less than x is less than or equal to 1. Okay, so interval notation and graph. Again, I like to see the graph first. So I'm going to sandwich, I'm going to shade everything between -2 and 1. I'm doing a parenthesis on the -2 because of that less than symbol. I'm doing a bracket on the 1 because that's a less than or equal to symbol. And then from the graph, it's really easy to see, oh, parenthesis -2, comma 1 with a bracket. Okay. All right. Now we're going to skip that. I haven't been doing that lately. Okay. Absolute value inequalities, that's going to be on the next video.